Hi, my name is Andrew Bethia, and I'm going to be talking to you about relative abundances of isotopes, how to find them. And this is all found on page 17 of chapter 1 of your study guide, the ACS, Atomic Structures? Atomic Structures. So let's turn around and get into it. Okay, so chlorine occurs naturally as a mixture of two isotopes with atomic masses of 34.97 and 36.97 AMU. What are the relative abundances of these isotopes? And we have four options. We have A, B, C, and D. A is 24% and 76%, 50% and 50%. C is 76 and 24%. D is 95 and 5%. And the first numbers correlate with the first AMU and the second number correlates with the second. So what I like to do is I like to identify all of the important information in the question first. So we're dealing with the atomic masses of this number and this number. And what are the relative abundances of, okay, so it's asking what are the percentages? What are the percentages of these numbers in chlorine alone? So chlorine occurs naturally with a mixture of two isotopes. So if you were to put these two isotopes together, what is the percentage? Because essentially what they're saying is this number, let me get a different color for you. This number in percentage and this number percentage should both equal 100%, which is what chlorine is. So let's do that. Let's get that all situated out for you, okay? Okay, let's go. First, we're going to need the atomic mass of chlorine. And where can we get that? We can get that from our handy dandy chemistry book, or just any other periodic table, but mine just happens to be in my chemistry book. Chlorine, 35.45. So as you can see right up here, 35.45 is the atomic mass. 35.45. Let's check that one more time because I'm not sure. 35.45, and that's good, 35.45, we're good. Okay, so remember I told you that this is basically the combination of these two isotopes and percentage-wise. So we can, just for laughs and giggles, put this 100%, just to help you understand that. So we're gonna say this is isotope number 1. And this is isotope number 2. The percentage of isotope number 1 plus the percentage of isotope number 2 should equal the atomic mass, the average atomic mass. Now let's get into the math, the nitty-gritty of it. I find this easier to set up a table to help me visualize everything. You don't have to do this. You don't have to do this, but I find it helpful. So we're going to have our masses right here, and we're going to have our percentage over here. So we have chlorine of 35 and then 37 chlorine. And of course we rounded up for these numbers over here. This is 36.97, 34.97, 35, 37. Okay, the mass of isotope number 1 is 34.97. The mass of isotope number 2 is 36.97. And the percentages, well, we don't know what the percentage is, so we can say that it's X. So whatever this number is, we're going to be subtracting it from 100%, because remember, the average atomic mass is 35.45, and this equals 100. So if you were to subtract isotope number 1 from 100, you'd get isotope number 2. So 100%, or in the decimal form, is just 1 minus X. Now let's go back up and find what our atomic mass for chlorine is, 35.45. So 35.45 equals 34.97 multiplied by X plus 36.97 multiplied by 1 minus X. And now what we're going to have to do is we're going to have to solve this algebraically. So we're going to distribute 34.97 to the X, and then we're going to distribute 36.97 to the 1 and the X. So we're just going to boop, and then boop, and boop again. So now our new equation looks like this. Remember, since this is a negative x, we have to distribute the negative with this new number. All right, we're almost done, almost there. Let's see, it looks like, we'll move this on over to the other side first. It seems easier. When it comes to math, I always find the easy way out. You didn't hear that from me, you did not hear that from me. Although in life there are no shortcuts. So let's bring out our handy dandy calculator. Alrighty, so 35.45 minus 36.97 equals negative 1.52. And we're gonna bring everything over to where it belongs, minus 36.97x. And because these are like terms, you can just subtract them. So 34.97 minus 36.97 equals negative 2. So this is going to be our new, oops, almost forgot the decimal. Let's start that over. 0.52 equals, negative 2x. Okay, and we're almost done guys. This is great. The easiest part we can ever imagine. Just divide by negative 2, divide this side by negative 2. Negative 1.52 divided by negative 2 equals 0.76 equals x. So what we found here, 0.76. This right here, this number all the way down here is going to equal this. That's the percentage. So what we can do now is the percentage of, 0.76 is the decimal version of 76%. So we can say that isotope number 1, the percentage of isotope number 1 in chlorine is 76%. And since this x is the same as this x, all we have to do is say 100 minus 76 equals, well, for those who can do it in their heads, do it in your heads, but for those who like to make sure everything is correct, do it in your calculators, 24. So this is going to equal 24, so that means this is 24%. So 35Cl is equal to 76%, and 30Cl is equal to 24%. So let's go all the way back up and check what our answers are, our answer choices are. Let's look at A. 24% and 76%. That doesn't, those are the right numbers, but they do not look like they're in the right order. So that is not correct. B, 50% and 50%. You know, we didn't deal with 50% at all in this problem, so that's wrong. D, 95 and 5%. We also did not deal with those numbers. We did not get those at all. So that means by process of elimination, the only answer that is correct, the answer that we solved, that we understood, is C, 76% and 24%. Alrighty, I think that's it. All right, that brings us to a close. I hope you were able to understand everything, prepare you for the ACS exam, hopefully, and have a great day. Thanks for watching.